So we're going to start out in 1.5. We're going to be talking about very basic rules of inequalities, okay? We're going to go to more difficult stuff in 1.6, kind of a combination of the rules that you would have seen in an Algebra 1 course. Okay. So first, let's talk about our first new definition. So in the inequality realm of things, there's a rule called the trichotomy rule. And it basically just says that for any number, let me get my pen started. For any numbers A and B, one of three of these is true. Either A is less than B, A is equal to B, or A is less than, or greater than B, I'm sorry. So only one of those things can be true. Either A is less than B, A is equal to B, or A is greater than B. Now, mathematically, that may sound silly. Yeah, if we compare two numbers, they're either equal, one's less than it, or one's bigger than it. But there's no other thing we can do. But what that allows us to do then is it allows us to apply some of the properties for equality in equations to inequalities. So it's just kind of a mathematical thing that we know is true. If we compare two numbers, they're either equal, or one's less than, or one's greater than the other. That's it, okay? Now, addition and subtraction properties for inequalities is a very basic thing. You can add or subtract any number to both sides of an inequality, and it will still be true. You can add or subtract any number to both sides of an inequality, and inequality, and it will still be true. So that just means some of the rules of equations. Let's think if we had something added to both sides, we need to get rid of it by subtraction. So this just is a rule that allows us to do that. So you're allowed to add something to both sides to the inequality, doesn't hurt it. You can subtract something from both sides, doesn't hurt it. So you can add or subtract any number to both sides of an inequality, and it will still be true. So that just allows us to use some of our rules of equations. So let's take a look at example 1. Let me make this a little bigger. For example 1, we're going to treat that, even though it is a less than. Now let me remind you of the symbols. That symbol is less than. That symbol is greater than. If you put the little equal bar onto it, it is less than or equal. Greater than with a little bar under it is greater than or equal. Okay? Now, we'll talk about the graphs in a minute. So, but you need to recognize what your symbols are. So your less than is the arrow pointing to the left, greater than is the arrow pointing to the right. Less than or equal to has a little equal bar under it. Greater than or equal to has the greater than symbol with a little equal to bar under it. So those symbols you got to know. Okay? So if we take a look at example 1a, just think of it as an equation. How could we get that y by itself? What would we have to do? How would we get that y by itself in this, if this were an equation? How could we start and solve that? We would have to get rid of that subtraction by 6 by adding 6 to both sides. Well, the subtraction and addition properties of inequalities say that we're allowed to do that. It doesn't change anything or hurt anything. So we would get that y is less than 9. Now, a less than symbols are going to shade to the left. These two are going to be open circles. These two are going to be closed. The closed indicates that we are being equal to that value. We're allowed to be equal to that value. The open circle says that we are not. Less than, we're going to shade to the left. Greater than, we're going to shade to the right. So if we put all that into play, y is less than 9, what I want to see on your graph, you really only have to show me 8, 9, and 10 if you were drawing it by yourself. I want to see an open circle at 9, and I want you to shade to the left. What that means is the values that are going to make that inequality true are 8, 7, 6, 5, and all those numbers in between. So going to the left. So you should be able to pick any number along the number line from the left of 9, and it would make a true statement. Okay? Now let's go ahead and do example 1b. Before I jump to example 1b, are we good with example 1a? No problem. Okay, so I'll let everybody catch up. But the main thing to remember is if you add or subtract anything on both sides of your inequality, it doesn't hurt anything, doesn't change anything, just keep going with that problem and rewrite it. So example 1a, you notice, is just a very one-step inequality, like a one-step equation. We don't have to worry too much about the steps. But example 1b, we have a little bit more to go. So if you look at example 1b, we have just more math we have to do to get that one. So that 5x plus 3, that's a greater than or equal to symbol, is greater than or equal to 4x plus 2. So let's go ahead and try example 1b. Now for this, it really doesn't matter which side you move things to. But for an inequality, it is more efficient if we bring the x to the left because of the fact that we want to make sure that we can see, do we have a greater than, do we have a less than? So let's subtract 4x's from both sides so that we get x plus 3 is greater than or equal to 2. So all we've done, you'll notice, is we've subtracted 4x's from the 5x's, and that's 1x. Now, if you put the 1, it's not wrong. You don't necessarily have to put a 1 coefficient, but you could if you really wanted to. What's our next step going to have to be? What are we going to have to do next? What do we have to get rid of? The 3, right? We have to get rid of that addition by 3. And so we're going to do that by subtracting 3 from both sides. So just treat it like an equation for the most part. You just go ahead and move things around by adding and subtracting things. And in this case, we get that x is greater than or equal to -1. Now our top one was an open circle, and we shaded to the left. Now, the open circle was because we didn't have an equal to bar. The left was because we had a less than. For 1b, we have a greater than or equal to. The greater than is going to shade to the right. The equal to is telling us we're going to make a closed end dot. Okay? So that symbol, once we've solved for it, then you decide, does it have the equal to? Make it a closed dot. Are we going less than, greater than? Less than will shade to the left, greater than will shade to the right. So go to -1, put a closed end dot. And then if you could, please, you would shade to the right. Okay? Now, in example 1, A and B, we'd only had to move things around. We just had to add or subtract things. but we do have to be a little more careful about multiplying or dividing things. So some people are still finishing example 1. Do we have any questions about example 1 before we move on to the multiplication and division properties? Any questions there? Okay. Now the next property we need to deal with is our multiplication division properties. You are allowed to multiply and divide by any number on both sides. But here's the rule, okay? So you are allowed to multiply and divide by any number but 0. As long as you do it to both sides. And here's the main rule you got to remember. If it's negative, whether you're multiplying or dividing, you have to flip the symbol. Okay, so let me say it again. You're allowed to multiply and divide by any number on both sides, except for 0. If you multiply or divide by a negative, you have to flip the symbol. Otherwise, the whole thing is treated like an equation. Nothing fancy, nothing major you have to do. But if you multiply or divide by a negative, you have to flip the symbol. You have to, or it will be wrong. Now, why is that? Negatives indicate a switch in direction. So if we multiply or divide by negative, what was once negative now becomes positive. What was once greater than now becomes less than. So it switches the direction of your symbol, okay? So you're allowed to multiply and divide by any number on both sides. If you do, and it's negative, flip the symbol. Only if it's negative. It can be positive, but that's fine. But if it's negative, just flip the symbol. That's the only extra piece you need to know about inequalities versus equations. That rule right there. Multiply or divide by a negative, flip the symbol. You got it, okay? Okay. So that moves us on to example 2 and 3. How are we going to solve example 2? How would you solve that if that were an equation? What would you have to do? Natalie, what do you think? If I were to solve this right here for x, what's the first step I would take? So I want to get the x by itself. So how would I solve it for x? So be careful when they're next to each other. That means multiplication. What's the opposite of that? So you're going to divide. So I always think if it's touching, just divide it off. So what you're going to do for this point is you're just going to put this under each side. That will indicate you're dividing off that negative 4.2. Because technically that means multiply. When it's touching the x, I have negative 4.2 times x. So I have to divide off the negative 4.2. But what did I say the rule was that we had to remember if we were dividing by a negative? Flip the symbol. Let's put a little... I circle my symbol. I tend to be a little bit forgetful. It's just a little visual reminder. Hey, that means next time I see it, I need to flip it, okay? So if you do that, now we're going to write it as a greater than or equal to. Two negatives are going to divide and make a, two negatives divided make a positive. So we know it's a positive. 29.4 divided by 4.2, and it is exactly the number 7. Now that it becomes a greater than or equal to, that tells me close in the dot and shade to the right. Close in the dot and shade to the right. The equality tells me to close in the dot. The greater than me tells me to shade to the right. Okay, so go to your little graph. Put a closed in dot at 7. Greater than 7, shade it to the right. Now, if you take pre-calculus next year, we will start to add a notation that matches that interval that you have shaded. For us, for now, I just want to make sure we're solving them efficiently so that if you take pre-calc next year, you're ready to go. Okay, everybody good with example 2 so far? If you multiply or divide by negative, flip the symbol. Otherwise, it's exactly like an equation. That's the main thing to remember. Okay, let's take a look at example 3. The first thing I would do for example 3 is that 6 is divided on the right. The opposite of that is multiplication. So this is one where cross-multiplying or multiplying both sides times 6 is a really good way to just knock that 6 off of there. Now, that's not the first step we have to take. I'm just telling you it's a first step that's it's convenient to do, okay? So your negative times your positive is your negative 6. I'm sorry, negative times a positive is negative. 6 times 4 is 24, so that's negative 24c. And that will equal the top of that fraction. Because what's great now is the 6 is canceled out by cross-multiplying. Okay, so now it's just a pretty standard equation. You notice I didn't flip the symbol because I multiplied by a positive thing. So I didn't have to flip the symbol in that first step, okay? Next, I would probably want to get the c's together. So why not subtract 5c's from both sides? We get negative 29c is greater than 58. I still didn't multiply or divide by negative. Subtraction isn't the same. So symbol is still a greater than. What's our last step we have to take to get that c by itself? What do we got to do now to get that c by itself? Yes. Divide by negative 29. But what do we got to do? Extra, because we're dividing by a negative. So let's circle that symbol. So the next time we write it, hopefully that will be a visual reminder. Hey, flip it. Okay? So we get, I'm going to kind of write it over to the side because I don't have much room, that c is greater than negative 2. Oh, did Mrs. Hott flip it? Oh, she did not. C is less than negative 2. Okay. So let's go over one more time how we solve this inequality. Multiply both sides by 6. Symbol is still greater than. Subtract 5c. Symbol doesn't change. Divide by negative 29. Symbol changes. That's why we have the symbol now is a less than. So I'm glad I remembered. Okay, told you I remember. So, okay. So on your graph paper, we have to have an open circle at negative 2. Less than is shaded to the left. So go over to your graph paper, find negative 2, put a little open circle, shade to the left. Now you can check these. You can check these very quickly. If you just pick one number, let's just go, let's see. Let's just pick, I don't know, let's pick negative, I'm thinking here. Let's pick negative 8. So negative 8 is one of the numbers I colored in. It could be any number that you colored in, but I colored in negative 8. So let's plug in negative 8 and see if it works. Is negative 4 times negative 8 greater than 5 times negative 8 plus 58 divided by 6? If that is true, if it's a true statement, when I plug in one of the values I colored in, then I'm probably good to go. So that's 8 times 4 is 32. And is that greater than negative 40 plus 58 is 18 divided by 6 is 3. Is 32 greater than 3? Yeah. So that is true. So our answer is C is less than negative 2. Okay? So the main thing I want to remind you again, if you multiply or divide by negative, flip the symbol. Otherwise, it acts just like an equation. You can add or subtract whatever you want. You can multiply and divide by positives. Nothing else hurts it. Any questions about example 3? Any questions about example 3? Our last example is kind of like more of a real-life applications where inequalities come into play. Okay, so let me read example 4 to you. It says, Rosa's cell phone plan costs her $50 per month plus 25 cents for each minute she goes beyond her free minutes. How many minutes can she go beyond her free minutes and still pay less than a total of $70? Well, let's think about what she pays. She has to pay her $50 bill. And then if she goes 1 minute over, she pays 25 cents. 2 minutes over, she pays 50 cents, and so on. So for every minute she goes over, if we multiply that by 25 cents, 0.25, we're going to find the cost that she's gone over that adds on to her bill. And we want that to be less than $70. Okay? We want that to be less than $70. So it's just an inequality, now that we have it set up, that we got to solve. Now, like an equation, let's get that m by itself. Technically, for an inequality, it's very helpful to keep it on the left. So let's subtract 50 from both sides. We get 0.25m is less than 20. So you just go ahead and subtract off 50. Subtraction doesn't change the sign or the symbol. Divide off the 0.25. And we get that m is less than 80. Now, there's not 80 on the graph paper, so let's just make graph paper over here that kind of matches. Let's just count by tens. In real life, technically, if you were to put on your paper an open circle and then shade to the left, that matches the inequality we got. But in real life, would she have negative minutes that she would use? No. So technically, for a real life kind of more accurate solution, instead of just open circle, shade to the left, I think we should kind of stop at 0, because 0 minutes would be more realistic. They didn't tell us how many free minutes she gets. So let's say that she only gets 50 free minutes. So then we really should shade between 50 and 80, would keep her under the $70 limit. So, sometimes with a real life application problem like this one, if you were doing this to match your inequality, you would shade everything to the left. But technically, negatives aren't used sometimes in real life applications. But I would give it to you either way. Okay. Any questions on the example 4? Makes sense? Okay, so inequalities are pretty straightforward. Your homework is the problems 10 through 22 that you see here. Ignore the little circles on there. That was just, and so you have the rest of class. This is technically going to be due both 1.5 and 1.6 on the end of class on Thursday. So if you did not, if you don't get the 1.5 homework now, you do have class time on Thursday. Any questions?